Is this thing on? Oh, hi. Hello. I'm just making fun with you. So this is a lecture video for 1314 section 3.6. We're going to be doing inequalities. The difference between us in 1314 versus what they do in 1414 is that we can use Desmos graphing. Yay! So we're going to use Desmos graphing for all this. It's going to be great. I'm going to show you how to do it by hand twice. And then everything else is Desmos graphing. So here we go. Inequalities, what they mean is not equal to. So they have these alligator symbols. I call them alligators because they chomp the bigger one. And I want to just give you like a rundown of what I mean by alligator. You've learned this back in kindergarten, I'm sure. We got 2, we got 3, and I want to know which way does the alligator eat? And he chomps the bigger one, right? 3, it's bigger. Okay, that was not too bad. So let's do 5 and 1. So chomp the bigger one. What about 0 and 4? So then chomp the bigger one. But what about 0 and -3? Chomp the bigger one. Now, negatives are nasty. And so the alligators don't eat nasty things. They only eat like humans. Is that what they eat? Anyways, they only eat good stuff. So they won't eat anything nasty, okay? If they have a choice. Now, if they don't have a choice and it's something like this, and you have to pick which one, it's actually going to be the -5 because it's less nasty. This is really nasty. This is less nasty. So they'll go with the less nasty one, okay? Chomp the bigger one. So that's how alligators work. Now you learned about alligators. We got a biology class. Anyways, there's also an equal sign. I call them bearded alligators because a little beard on him. But like he's older, a beard, if you're not hearing me correctly. Bearded alligators. But that just means there's also an equal sign in there. If you have these guys, and going forward, how we're going to use these, use parentheses with these guys. And with the bearded alligators, you're going to use the square brace bracket things. We've already seen that before with our domains back in chapter 2. But now I'm just going to tell you once again to do that. Okay, so they use graphs, and that's cool, but I'm going to use graphs better. I'm going to use graphs better than what they have, okay? So, no. Let's go and do some of this. Whoa! This is actually really important right here, okay? We'll see that again in about a few minutes. But let's just do some work here, okay? Now, I'm going to do this by hand so that you're sad, okay? And then we're going to do it with Desmos, and then you'll be happy. And there you go. So fast forward, and we're going to do Desmos now. So I need to solve for x, and I get a 4, and I get a -5. And these are my boundary points. And essentially on a number line, I have -5, and I have a 4. And I want to know what's going on around them, like over here, and over there, okay? So I'm going to test out some numbers and see if they work. So I'm going to test -6, because it's somewhere over here. I'm going to put a little dashes here. And then what's an easy number between these guys? I'm going to test the 0. Hold on. And there we go. That's much better. Testing -6, 0, and +5. You could do like 500. It doesn't really matter. Just whatever you want to do. Let's just do 5. So I'm going to test these guys out. And I'm going to test them in Desmos Scientific so you just see that I'm being honest here. So we got -6 minus the 4, -6 plus the 5. And I got a 10. So I'm saying that my 10 is less than or equal to 0. You see that right there? Less than or equal to 0. Is 10 less than or equal to 0? No. So this does not work. Let's test the next one. So I'm going to do some zeros. So now I got 0 minus 4, 0 plus 5, -20. So I got -20. Is -20 less than or equal to 0? Yes. So that works. Here we go. Last one. I got a 5. So I got 5 minus 4, 5 plus 5 is a +10. Does +10, is that less than or equal to 0? No. So that does not work. This is the only working section, and because it has an equal sign, we're going to use the brackets. And so then I'm going to say it's -5 to 4, but I'm going to use the brackets on it. there is your final answer. Okay? Not too bad in the end. Not too bad. Desmos. And I want to tell you that I typed it in exactly as you see it here with the bearded alligator. To get that bearded alligator, you're just putting an equal sign. See? Without, I hit equals 0. There's your answers. And the shaded region is your answer. So it's trying to tell you right now that it's between -5 and 4. So it's between these two. We like this. Notice that there's solids here. You see those solid lines? I know it's kind of hard to see. Those are solids. Solids. Square brace or bracket. And then you're done. Woo! That was it. You can see why Desmos is so nice here. Let's do another one. I'm going to start with Desmos because I don't want to factor that, honestly. You can type it exactly as you see it. Kabloop, kabloop. Uh-oh. No way I can do that number. Shucks. Did it work? Did it work? Did it work? Oh, you can't get me. So anyways, what I'm saying is my answer is between -4 and 2/3. Okay, okay. Cool, cool. Notice, are those solids? Look, he's not a bearded alligator. We're supposed to use parentheses with this guy. So, bloop, bloop, and you're done. That was it! That was it! So, I don't know how else to do this. Like, I wanna just show you, like, I don't know. Let me do a graph. -4, 2/3. I mean, that's what we're doing in Desmos. So somehow have a reminder for what you're doing so that you can reference back to this. Okay. Okay, so I want to keep doing Desmos, and I will, but I want to do a little bit by hand. Just a tiny bit. It's okay. So then x cubed minus 7x squared minus x plus 7 is greater than or equal to 0. I could do factor by grouping. And I'm going to pull out a minus sign. Factor these to the front. It's technically a 1. And then you can factor that down. It's supposed to be a 2. I just kind of messed it up a whole lot. So my answers are going to be 7, 1, and -1. Okay, so those are my key numbers. On the number line, I'm saying I got -1, +1, and way over here at 7. And I got to test each one of them to see if it works or doesn't work. Blah, 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 blah. So let's instead, I'm going to type the very original. You can even do the modified versions. Oh, look. Now, here's the thing. Click, 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 and it's not letting me click. I'm trying. Okay, it's not working. It should show me a number, but if you scroll in, you can see it's -1, +1, 7. And we confirmed those numbers. I confirmed them. So you can always do this a little bit by hand just to make sure that you're doing the right thing. Okay? So I got my numbers, and I want the shaded regions. So it says that it's going to be between -1 and +1. And then from 7 to infinity, right? Because this right here, that's 7. And see how it goes off to infinity? Whoa. That was my stylus. I'm sorry. So anyways, how do I translate that? So I'm going to say -1 to 1. And again, notice that we have this guy, so we're going to use brackets on this one, right? The bearded alligator. So bracket, bracket, union, bracket, 7 to infinity. There's your final answer, and we're done. So a little bit of by hand kind of helps a little bit, but in the end, I would say Desmos really helps, especially for this one. Now, pause. I got to tell you, this guy right here in Desmos is not going to be friendly. They purposely said, oh, we know Chad's going to use Desmos, so let's not do anything like that. Yeah, okay, there's a lot of ways that we can still get this thing to work. But I just wanted, it's just a funny little problem here, okay? It's a funny one. So they're saying, where's the domain? And this graph, it does this. And I know that's a 9. I have no idea what this guy is. But that's a 9. And I'm saying, basically, negative infinity up until question mark. Okay? And then I stop. That's a solid. So I use a bracket. Union, bracket, 9 to infinity. This is your answer for the domain. The only thing missing is this guy. I just need to find out what my question mark is going to be. So how do I find that? And you're thinking, oh, well, I can do 4, 8, blah, 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 blah. It's not going to work. It's not going to work. I'm going to tell you, it's not going to work, okay? Because it's not one of those repeaters. But there is a 7 here. There is a 7. So let me try to, like, do this properly. 4, 2, 8, 5, 7. 4, 2, 8, 5, 7. Again, I'm just, like, trying to show you. It ain't going to work. But what if I tried some funny numbers, okay? So, okay, there we go. What if I did 1/7? Is that the same? No. 2/7? No. 3/7? Look. Here, I'm going to scroll it up. Look. They're the same. Oh, it's 3/7. So, how did I know that? Like, how did I know it was going to be a 7? Because there's a 7 in the front. There you go. Now you're done. So yeah, that was 3/7 the whole time. Can you do this another way? Yeah, you can do quadratic formula of the inside. I'll wait. No, I ain't going to wait. So anyways, you can do that. You can also say, oh, I know 9 is one of the answers. So you could do synthetic division. 9 times 7 is 63, leaves a 3 behind, 27, zero it out. And so this is 7x minus 3 equals 0. Add 3 to both sides. Divide by the 7. And there you go. So we can solve it that way also. There's a lot of ways to do this. Lots of ways to do this. This is on your homework. It does come up. Now I'm showing you how to do it. Okay? Are there other ways to do it? I guess quadratic formula. Literally the only other way would be quadratic formula. I ain't doing that. I don't want to do that. So you do that. Have fun with that. It'll be fine. AC method. I don't know. Whatever. Okay. Here we go. Keep cruising. Keep cruising. This guy here. This is a fraction. But I'm just going to treat it the same as everybody else. Okay. I can't click on those numbers, so I'm wondering where that actually is. And if you go, like, scroll in, you could see, yeah, it's not 9. I mean, we could see that. Or you could just look at it. Here's solve for x. Again, they're always opposites, right? -1 and 9. Now, here's some things to note. If it's in the top, then this is a 0. And if it's in the bottom, then it's a vertical asymptote, okay? Now, with zeros, it depends on what your alligator is. You can use this, or you can use this. It kind of depends on the alligator, okay? With vertical asymptotes, it's always going to be the parentheses. Now, if you go back up for a second, right here, look, it says never do this. What they're trying to say is always parentheses with vertical asymptotes, okay? Cool. So now you know. All right, so look at my answer. Look, it started at negative infinity up until -1, because that's one of my answers. So negative infinity up until -1. And look, that's not solid, is it? Not solid. Union, and then we start back up at 9. Again, got to use that guy. Off to infinity, and there you go. Again, we could do the whole number line thing. -1, 9, test. It's not worth your time. Okay, last one. This one's a little weird to solve, but if you move the x over, you'll see that it's x equals 4. Again, this is a 0. Notice that we have a bearded alligator, so we're going to definitely use brackets here. But on the bottom, when I solve for x, we get a 6. This is a vertical asymptote. It's definitely going to use parentheses. And so when I see those numbers, when I see this answer here, beware and know what things we're going to use where, okay? Okay, here we go. So you already see the 4 and a 6. Awesome. We already had those answers. Great. So I'm going to go from negative infinity all the way to the 4. union 6 to the infinity. So we got that far. But now what do I use where? Notice there's a solid at 4. And I already said we're going to use a bracket there. So cool. And parentheses should be for vertical asymptote. Awesome. Great. But notice one other thing with this 6 here. Scroll in. I'm going to ask, like, compare and contrast. You see, this is a solid. Does this have a solid? No, I don't see a solid there. Okay. Solid? Not solid. Not solid. Using parentheses. Or not square brace. So again, this is a 0. So we definitely had to use this guy because it's a bearded alligator. This guy here is a vertical asymptote. Yeesh. So always the parentheses, okay? That's it. No, we're not done. It's okay. Last one. Definitely last one. Here we go. And this is not too bad. I don't even read this. It's not worth reading. But this is easy. I'm going to use Desmos graphing once again. So we're at the top of a roof, and we're just standing here totally innocent. And we're going to toss a ball up and have it land on the ground. There's nobody down here. There's not going to be any blood. It'll be fine. So they're wondering, when is this ball above the rooftop height? And this is one of those problems where I stand on the desk in class. So if you want to take me lecture-wise, then you'll see me stand on the desk here, at least for the next few years while I'm still young enough to do it. Ha-ha! So, anyways, this is the height of the rooftop, they said, was 70. So I want to know, when is this ball above the 70 mark, essentially, okay? So there's two ways to do this one. I'm going to graph it first, I think. Graphing is going to be way easier, and I'm going to show you both of them. So definitely use X, not T. And then I'm also going to just put in Y equals 70 because I want to see that mark. You can see I got like the original, and then I got the 70. And so this kind of shows the height of the rooftop in a way. See, so right here is where it starts, and then goes up, and then back down. Boom. Boom. There's your answer. 0 and 4. 0 and 4. 0 and 4. Okay? It's just that easy. It's just that easy. Okay? You don't have to make it complicated. You're setting this equal to 70. You're canceling your 70s, and you're solving. Look, I'm doing it by hand suddenly. Why? I don't know. Factor out a t. Awesome. So this is t equals 0. If there's no other number, it's a 0. And then this guy, we solve for x. So I'm going to move the t over. So I got 16t is equal to 64. Divide by the 16. And what's 64 divided by 16 is a 4. Go figure. So those are my numbers, Desmos or not Desmos. And then last one, which one of them is it? We'll see how it says exceeds. So you need to exclude. That's the same language. Exceed, exclude. There's your answer, and we're done. Okay? That's it. It's just saying not equal to, essentially. Cool. Whew. And that's on the homework for sure. So now you know how to do it. It's really pretty easy stuff. Any questions? All right, great. Thank you, guys. Have a great day. Thanks for watching.